Hey guys, so my name's Lowell, and today we're going to be talking about stacks, one of the most useful data structures you'll ever use as a programmer for most programmers. You've probably already used one without even realizing it. Every time you hit undo in a text editor, that's a stack. Every time your browser takes you back to your last page, that's a stack. Even the way Java runs your own programs, the call stack, that's a stack. So by the end of this video, you're going to know exactly what a stack is, how it behaves, and how to build one exactly in Java using an array. Let's get into it. Also, a little side note, stack, it's what it sounds like. It's a stack. So it is easy to overcomplicate it, but at the end of the day, it's better to simplify. So here's what we're covering today. We'll start with the concept, then look at the operations, and then do some real examples, and then write the actual Java code from scratch. So let's do that. So what is a stack? This is a pretty good diagram right here. I didn't make it, I took it offline. But a stack is basically a data structure that follows a really simple rule, last in, first out. You might see it written as LIFO. Think about a stack of pancakes, or what we have right here. You just think of them as pancakes. You put the first pancake down, then the second on top, then the third. When you go to eat one, you take one from the top. You can't grab from the bottom without messing up the whole pile. Same idea here. So it's the same idea. Yeah, you take it from the top. Um, you push it, and you can pop it out. This is what programmers use for the terminology, but that's what it is. So last in is the first out. So last one you put in, first one you take out. I know I'm reiterating myself and just repeating myself, but that's the core concept. What makes a stack a stack? A stack only gives you access to one element at a time, the one on top. You can't reach in and grab element number 3. You can't insert something in the middle. The only things you can do are 1, push, which means add something to the top, 2, pop, which means remove the top item, 3, peek, which means look at the top item without removing it, and 4, check if the stack is empty. That's it. 4 operations. Simplicity is actually what makes it really powerful. They're fast, predictable, and show up everywhere. Maybe I should switch to this, but that's basically what we just talked about. So cool active recall practice. You can be like, wow, we just talked about it, and it's right here. So that's pretty good. So now for some real world examples. So we have the undo button. This one isn't too bad, but let's type right here. So I do this, Command Z, because I'm a MacBook. That just undid it. That's a stack. So this is last in, first out. That's what it is. So when I hit Control Z, the program pops the most recent action off the stack and does it. Last in, first out. That C was the last thing I typed, so it's the first thing undone. I have something a little bit different written here, but yeah, I have like A, B, C. Okay. Okay, there we go. That one worked. So got rid of the Z, not the entire thing, but they got rid of the Z. So that's a pretty good example of how stacks work. Now we can do browsers. Let's look up something. I don't want anything bad. Okay. So I have Wikipedia merch, right? I really want this merch. This is tough merch right here. Hold on. I'll show you real quick. I'll go off topic a little bit. Dude, this is so cool. Anyways, like this one right here, like I'm gonna show up to class one day with one of these, like this one. I want the climate change one. Like this is cool. Anyways, when I click back, same idea. It reloads the page. Every page you visit gets pushed onto a stack when you hit the back button. So see, it just took me through everything that we just went through, and I can go back, and it's really just like a stack. That's exactly what it's like. It has a pretty good name for it. So we're gonna build one now, or I already kind of built one. This one right here. But let's explain this before we straight up build one. I mean, you can kind of see I'm kind of spoiling it here. But we're going to use an array to store the elements and add an integer called top to keep track of where the top of the stack is. So we'll start at top equals -1. This is common for programming. It just means that the stack is empty. It usually means something's empty. You're returning it. So -1, meaning the stack is empty. Every time we push, we increase top by 1 and put the item there. Every time we pop, we grab the item at top and decrease top by 1. That's it. So yeah, pretty self-explanatory. Top is 1, top is 2. After pop, it goes back there. So yeah, I don't want to mansplain it too much. I know that's kind of my job here, but that is it. So now we're gonna create a file. Actually, we're actually gonna do a Java file right here. Excuse my mess of a computer. Wait, I think I could do this. I'm only human after all. So I do have a lot of code here from my previous assignment. Or no, I don't. Okay, so ignore what I just said because we're doing pretty good. So let's go right here and let's start with public class stack. So it's important to remember this might not completely compile. It's the idea that counts. So let's start with the private int for data. We want it to be an array. And let's add some comments here. So this is the array that stores our elements. I also have a speech impediment, so you know I may say things wrong every once in a while, but I am locked in. Then we have private int top, and this is the index of the top element, kind of self-explanatory. And then private int capacity. This one isn't too it's not too intuitive what it means, but it's a max number of elements. So this is a really complicated way to just say capacity. That's what a capacity is. Programmers love to complicate things in their ever dying quest to make things as simple as possible. They really complicate things, and maybe that's just the nature of programming in of itself. But you will notice that a lot of programming, for me at least, has been how much can I dumb this down? That's about it. I think it's every programmer, honestly. Not too special there. So now we're gonna have the constructor. We already defined this up here. So this capacity equals capacity, pretty straight up. Then this data equals new int, okay, int capacity. And then this top equals, remember we set it equal to -1 at first. And then, and yet again, I'm going to reiterate it, means empty. I know it's weird going before 0 here when we don't normally do that. And then we can, I guess we can add our little, I forgot to add this, little curly bracelets or brackets or whatever terminology you want to use. So yeah, we have 3 fields: the array called data, an integer called top, starts at -1 again, and the capacity. The constructor takes a size and sets everything up. Then let's write some helper methods. You always have to have helper methods. So let's go down. These are common to see. And basically for this one, it returns true if it's -1. So nothing has been pushed yet. It's something hasn't pushed yet. I almost spoiled it, so let me write the next one real quick because I'm jumping out of my seat of enjoyment while typing this. I cannot wait to show you guys what happens next. But right here, we have return top. So this is capacity though. I really hope I don't type anything wrong here. Capacity. This is why I'm an engineering major and not an English major. I spelled that right. I think I did. But yeah, so now we have is full, and this returns true when top has reached the last valid index, which is capacity -1. We need is full because arrays have fixed size. We can't push to a full stack. So this is, we were talking about this. This is the push one. So let's do public void push int value. And then if is full, because if it's not, we just return -1. Well, that's not entirely true. But we do system.out.println, and then you can write whatever you want here. I already have this written. Stack is full. Cannot push. Yeah, you do not return empty. This is specifically if it's full. That was a blunder in my move. I was just talking. I love to talk, believe it or not. Make sure to have standards too when you're turning something in. I tend to forget that. My standards would be like right here. I tend to forget that. But okay, but that's not good. Maybe not best place for bracket. So we have top. So this moves top up 1 spot. I have move. I don't know if that's grammatically correct, or punctuationally correct. I don't know. I'm gonna put moves top up 1 spot. I don't. Maybe you can put moves. I don't know. This is a comment though, so it doesn't matter. And then we will have top right here equals value. So it checks, and doesn't check. It does technically check, but it stores the value there. And the first thing we want to check is the stack full? If yes, we can't push, so we print the message and return. Otherwise, we increment top first and then put the value at that new index. Notice the order top plus plus first, then store. That's important. If we stored first and then incremented, we'd overwrite whatever is at the current top. So let's do the pop one now. We had push. Let's do pop. I have a theory that the pop is going to be somewhat similar, because in a way, it's not the reverse of it necessarily, but it's similar. So this one is if is empty. You can do system.out.println, and then stack is empty. Empty cannot pop, which is a no-no, or not a no-no. It's whatever your perspective is and whatever you want. And then we can return -1. And this is a fancy word. We already talked about this. I feel like I've talked about why -1's used in programming more than stacks here. But it's a sentinel value. I haven't looked up the word root for that, why that's chosen. But yeah, that's what programmers call it. And then, excuse my placement of curly brackets. We do int value equals data top. So yet again, right here, we're going to be grabbing the top value. So grab the top value. And then this is minus minus this time. And then we'll just move the top down. And then we can return value, just like, is it similar to the last one that we just did? No, interesting. And then we can return what we grabbed. So what I have right here is we should check if it's empty first. If the stack is empty and you try to pop, that's called a stack underflow, and that's an error. We handle it gracefully here by printing a message and returning -1 as a symbol, as a signal. Like, it is a symbol, but it's a signal. If there's something there, we say the value at the top index. Decrement top, decrement top. You don't say that a lot in common language. And return the saved value. Notice we don't actually erase the old value from the array. We just move the top pointer down. That old value will be ignored and overwritten next time we push. So peak, so we're gonna write peak. So it's a good way to word it is it's just like pop, but we don't remove anything, we just look. So I did hint at this last time when I said that we checked. I didn't forget the exact terminology I used, but I said that it checks to see if there's something there. And then I was like, no, it actually places, it stores a value, but technically it does stack. So we're gonna see that this is probably going to be very similar to pop, because pop has to check first. It has to. How else would we know if something's there? But we're not moving anything. We're purely peeking or looking. Peek's a little cheeky way to put it. So yeah. Let's see how similar it is to what we wrote before. Besides from the outprint line. And then stack is empty. Nothing to peek at. That's if it is empty, as it has been foreshadowed. So, man, I love writing code. And then if it's not empty, we return data top, which is what we're looking at, because we can't really look at middle here. And then we can return top without changing top. See, now that's very simple. Can't control my coughs. So simple, we just return data at index top without touching the top. Great for when you want to check what's up top before deciding whether to pop. Yeah, duh. That's just great when you want to peek and not do anything. Pretty useful. So now we're going to do a toString. You always need a toString most of the time whenever you write anything ever in Java. I don't know if that goes for all programming. I'm going to assume it does somewhat. But yeah. So here we can do public string toString. And then if is empty, we can return empty stack. That's not correct. Well, actually, it is, because it's in parentheses, so you can put whatever you want there. You can actually do whatever you want. Whatever you want. Like, literally do whatever you want. If you want this to be right, you should follow this. Then we can do the string result, which will be equal to stack, and then top minus bottom. Sorry, my code has an arrow there. I don't know how I would insert, like it's correct. I just don't know how I would insert an arrow in Java here. So assume this to be an arrow. I don't know how to insert an arrow. This is another syntax thing. It's top to bottom, not minus bottom. But yeah, syntax. I don't really know how to put that in Java, but let's move on. For int I, this is just a loop, equals top. We're very familiar with this. Everything comes back to being comforted again. And then 0, and then I minus minus, curly bracket, bracelet, or something along those lines. And then data I, and then if I is greater than 0, result. Apologies if my humor is setting you guys off while watching this. It's always been my lifelong dream to be a YouTuber or something of the sort. So I hope maybe I can make programming a little bit more fun for you guys watching this. But yeah, so here we loop from top down, index 0, printing each element, top down to 0, until you hit 0. That way the first thing printed is the top of the stack, which makes it easy to read. It's also by definition kind of what we have to do here, because that's stacking. And then here we have this right here. So cool, if you're on JGrass and you're on MacBook, here's a little tip. So hold down the command key, and scroll on your touchpad and you could zoom in like this. This is not common knowledge anywhere, by the way. Like, I should make another video telling people how to do this, because this is just like, I've accidentally done this, and I had no idea how to fix it. People like, oh, go to like tools or window and view it. No, I'm sure it's similar to Windows, but for MacBook, you hold down Command and then you scroll like this. So here is the whole code. If you guys want to copy this down, you want to look at it later, or anything similar, there it is. So we should run this and see if it runs. Yeah, I definitely forgot some semicolons there. I am back. I did some mining off camera. It wasn't too much. I'm already going past the 20-minute time right here. So what I had messed up in the stack.java was just small stuff. I could go over it, but I don't want to bore you guys, and I'm also past the 20-minute time limit. But I just forgot like some brackets and some, like, it was trivial stuff. It wasn't anything majorly important. It was just it was just debugging. I also found out how to do the arrow. I just looked it up. But I just did the dash and then quite literally did this. So I overthought it, but we need something to test. Oh yeah, I spoiled it right here, but we can compile this and it works, but we need something to test it with. So here is a test.java. I'm gonna explain it a little bit. But you create a stack, my stack, new stack. We're gonna do 5 here, and then push, right? So it's in order. You print it, peek at the top, you pop the values one by one, you stack them, you print stack. The code does the stacking, right? And then try popping until empty, and then this. So we will run this right now, and there we do. So we can see it being played in motion. It's empty, cannot pop, it's full, cannot push, and we can see this actually working. So this is really cool. I would love to go over this more in detail, but the test is more to do on your own time. This is a really good example, so if you need one, you could use this one totally, but making the test super duper helps, and what I'm trying to help you guys understand is the concept. But I'm going to leave you guys off with this one. Stacks seem simple, and they are, but they show up with some really important algorithms later on, like depth first search, expression evaluation, and balancing parentheses. So getting comfortable with this now is going to pay off, as literally anything goes in your life and in the world. Getting comfortable with the foundations and basics will pay off. So I'm not telling you anything you don't know. If you want to extend this, try making the stack work with strings or objects using generics, or try implementing a stack using a linked list instead of an array. Good luck. I'll see you guys in the next one.